Hello everyone, we are Team Bug Mafia. We present to you our solution for Problem Statement ID SIH 25069 of Smart India Hackathon 2025. We have developed an AI-assisted life cycle assessment platform built to help the metallurgy and mining sectors make rapid, defensible decisions that advance circularity and sustainability. The motivation for this work is simple. Metals such as aluminium and copper move through long value chains from extraction and refining to fabrication, use, and end of life. Traditional linear approaches prioritize throughput, often at the expense of resource conservation and waste reduction. Our solution bridges that gap by combining established life cycle impact factors with machine learning to fill data gaps, quantify circularity, and produce clear, actionable recommendation in a format engineers and decision makers can use immediately. Now we will walk you through what it does and the technical aspects of the tool. Our project uses a modular machine learning pipeline to predict environmental and circularity indicators for metal and materials. It begins with data preprocessing, where raw data is cleaned, normalized, and transformed using a structured pipeline. Feature engineering helps handle missing or inconsistent values, ensuring accuracy. Next, in model development, we tested algorithms like random forest, XGBoost, and gradient boosting. Random forest was finally chosen for its balance of performance and interpretability, with hyperparameters tuned for best results. For explainability and visualization, we use SHAP values to interpret model predictions and visualize the influence of each feature. Tools like Plotly and Matplotlib help present clear, data-driven insights. Together, this end-to-end architecture ensures accurate, interpretable, and action-level analytics for sustainable material assessment. Now, let us see a demonstration of our website.
So here we have a LCA analysis tool. We can give different inputs such as material. We have given, for example, aluminium. We can select the weight of our material and the sources like primary, secondary, and the mode of transport such as truck, rail, and how much we have to transport, the distance in kilometers. We can select the process which we are doing in our industry and the energy from where we are getting, such as solar energy from grid we are taking. And yes, and then we have to input what is the product lifespan of our product and how we want our product to end, like what percent will be reused, what percent will be recycled and disposed. When we run an analysis through our website, we get result in which we get a grade. For this example, we have got a C+ grade and a circularity index of 51.9%. These four factors tell us about the total environmental impact. This is all the output we get. At last, we get some recommendations based on the SHAP analysis. Next, we move to dashboard. On dashboard, we get the cumulative report of all our samples. For example, here we have done 4 analyses up till now. From the report section, we can view and download the reports of our analysis.
So now let us go to the drive folder which contains all the files that are required for this project. So this folder contains the report, the dataset, presentation, and we'll soon add the video. So let us see the dataset. So this is the data that we use to train our model. We build the dataset by integrating information from trusted environmental and material sources such as ecoinvent, our world in data, and UN Comtrade. So here is the report of our presentation. So this report contains the detailed description of what is our project, how we did all the parts in our project such as data generation, feature engineering, and it also contains the results and all the graphs and the images that were generated by our model. Thank you. So now let us see the GitHub repository of our project. So the repository contains 2 branches, main and frontend. The main branch contains all the code and database that was used for training the model, and the frontend branch contains all the code for the website of our project. Thank you.